For compressible flow IQE number 8, I decided to do a tire with a punctured hole in it. I wanted to kind of create this concept or idea of what it would happen with the tire being choked and the velocity flow coming out of the tire, as well as what it would be the mass flow rate. Why can we assume that speed of sound can be approximated as c equals kRT over m to the 1/2 power for an ideal gas? For ideal gases, the speed of sound can be approximated by the equation above when the fluid flow has reached a Mach number of 1. It is safe to assume the K number is 1.4 for air at ambient temperature, 25 degrees Celsius. Then, in an ideal situation, K is independent of temperature. When it is a diatomic gas or a more complex gas, the K will depend on temperature, therefore decreasing when the temperature is increased. Thus, the speed of sound cannot be approximated with the equation above. So for the calculation question, you know that the P naught is 240 kPa gauge. We know that the T naught is 25 degrees Celsius, which is 298.15 Kelvin. And we know that the initial velocity is 0 meters per second. When the hole is punctured, a 0.01 meter diameter hole is created. We know that pressure atmosphere from the calculation statement above is 101.325 kPa. We want to find the velocity in meters per second and the mass flow in kilograms per second. We can assume that air is at 25 degrees Celsius, which means the K value is 1.4. We know that it's a compressible flow, there's a constant Cp and Cv, and there's negligible potential energy. We also know that it's isentropic. For properties, we can find that Cp equals 1.005 kilojoules per kilogram Kelvin. Cv is 0.7180 kilojoules per kilogram Kelvin. We know that the R is 8.314 joules per mole Kelvin, and we know that the molecular weight of air is 28.97 grams per mole. So for the solution, we know that the pressure in the tire has to be greater than or equal to P atmosphere times K plus 1 over 2 to the power of K divided by K minus 1. If it is below, the tire will be choked and it is equivalent to Mach number equaling 1. So when we do that calculation, we get 191.8 kPa. Therefore, it is choked because it is less than 240 kPa. Then we can figure out the pressure absolute by adding the atmospheric pressure to the kPa, or to the tire, the pressure in the tire, which would equal 431.8 kPa. We would have to find the area of the hole, which equals 7.85398 times 10 to the negative 5 meters per second squared. To find m choke, we can assume Mach equals 1 because of this this solution right here. When mass choked, it equals area times P naught equals K molecular weight over RT to the times 2 over K plus 1 to K plus 1 over 2 times K minus 1, which will give us this to equal 7.94 times 10 to the negative 5th kilograms per second. We have to find C to get V. So we know that the Mach number is 1, and in order to get V, we have to find C, which is C equals the square root of KRT, which equals 280.8 meters per second, which means the velocity is 280.8 meters per second as well. There we go.